So most of this, what we'll be discussing right now, most of you did in school, but I'm going to cover very quickly again the whole concept of electricity, where it came from. So everyone knows the basic atom model, where the Bohr model, that's what they call it. So you have the nucleus in the middle, and then you're going to have electrons surrounding it. Okay, so you're going to have something like this, where these are all electrons. And yeah, and these are basically called energy bands. You don't need to know all of this. All I need you guys to understand is that these are electrons, and these are negatively charged. This is very important. They're negatively charged. And these are protons and nucleons in the middle, which are positively charged. The protons are positively charged. Okay, and the nucleus is neutral. There is no charge to it. So it's protons and electrons. We're focused more on the electrons when it comes to electricity. So just the quick concept of how electricity works, how conductive materials work, and how insulators work, is that it depends on how many electrons are valence electrons or available electrons when it comes to in contact with a force that will allow it to transmit, basically causing there to be current. So the idea is, if we have an atom, okay, if we have an atom and it has electrons here, 4 electrons, the first band is filled, and then it has one valence electron over here, okay? So this is what they call a valence electron, as in a free moving electron. That's what this means. So it basically has more electron, one more extra electron in an extra band of energy. If a slight force is applied to this electron will freely move, okay? Meaning this will become negatively or positively charged. This will become a charged particle that will allow electricity or flow of electrons, basically current. And that's where electricity, the basic concept of it, comes from. The idea is you have either an positively charged atom, or it's negatively charged. Okay, if it's positively charged, all right, it will attract the negative charge. So the electrons will want to go towards it. And if it's negatively charged, the electrons will want to go away from it. Okay, that's the whole concept of, charge in general. If a body is positively charged, electrons will want to get attracted to it. When if it's negatively charged, it will repel electrons. And that's what will cause the flow of electrons, also known as current. So conductors are basically, what are conductors? Conductors are materials that have, the valence electron available to easily move, which basically allows current flow. All right. And then you have insulators, which do not have any valence electrons that are readily there to move. So it will basically block the current because there is no free flow of it. All right. This is the whole concept. The whole idea is the flow of electrons. That is what current is, the flow of electrons. All right. So if we go now to the electrical part, like electrical definitions, what is current in general? Current is, like I said, the flow of electrons. All right. Electrons are basically, like you saw earlier, electrons depend on the availability of valence electrons depends on the material, depends on a lot of things. So the first concept you need to know before we even get into current is there's coulombs, which is usually named as the letter Q, all right, which is basically a singular charge, all right. So it is also equal to the number of electrons over a constant number. I believe it's 6.24 times 10 to the 18, if I'm not mistaken. All right. The idea of this is to just know that if something is charged, it has a specific number of electrons over this constant, Coulomb's constant. All right. So the unit of this charge, Q, the Coulomb, 1 Coulomb, is the total charge by 6.24 times 10 to the power 18 number of electrons. That's the whole idea of it. We will see how we use this Coulomb in a bit, but first we need to know what voltage also is. Voltage is when you're talking about how much force you have or how much pressure you have that is allowing current to flow. So the higher the voltage, the more current you will allow to go. So voltage is basically like a force. You can think of it as a force. All right. A voltage is what allows the current to flow more or less depending on how much voltage you have available. And you think of it as if you have 10 marbles in your hand, you're trying to push them with your hand. How much force you're applying, that's basically the voltage when it comes to current. So if you're pushing them really hard, they're going to flow much faster. If you're pushing them very slowly, which is lower voltage, the current is going to be lower. But also, there's something called resistance. Resistance is basically the stopping force, you could say. You can think of it as kind of like friction when it comes to mechanics. All right, when it comes to mechanical fundamentals, it's like the friction force, which is pushing back at your voltage force, or it is slowing down the current depending on how much voltage is available or how much current is available. So this both affects the current. So we have something called Ohm's law, which I'm pretty sure everyone's familiar with here. Ohm's law, which basically says that the voltage is equal to the current times the resistance. If you notice here, if we keep these two constant, the voltage and the current, and we increase the resistance, by increasing resistance, if we keep the current constant, we're going to be increasing the required voltage to keep up that current. The same concept can be said about the current. So let's say V equal IR. We are increasing the current, we want to increase the current, and we want to keep the resistance the same without interfering with the resistance. So we will have to increase the voltage. And the same thing again can be said if we want to not change the voltage, we want to keep the voltage constant, but we want to increase the current, then we will have to decrease our resistance to allow more current to flow. So Ohm's law is the bread and butter. هذا الأساس الزبدة مثل ما نقول when it comes to anything regarding electricity. V equal IR always will define how current will flow in a circuit. In any circuit that is given, it will always be dependent on these three values, which is the voltage, the current, and the resistance. And we will see more of that later on. But before moving forward to that, I want to talk more about resistance specifically now. So the resistance. Resistance is usually dependent on the material itself. It depends on many factors, but it depends mainly on material. Yani whether it's a metal, it's a plastic, it's a ceramic, it's it's a compound material, or if it's an alloy. It depends on that. That's one of the things it depends on. It also depends on the length of the coil or of the wire. So it depends on how long a wire is, or how long the material is, or how big the material is. And to be more specific, how big a material is also the area of the material, the area of how thick or how wide the wire is in the case of the thickness or the resistivity of a wire. So these are the three most important things that affect it. And then there's also one more point, which is temperature. Temperature. All right. When it comes to any material, any material, resistivity will always depend on these four most important concepts. At constant temperature most of the time, it will depend mainly on the material and how much of the material you have in terms of length or in terms of width. So one of the formulas that basically relates all of these is, I'm pretty sure you've seen this a lot, which is the rho L over A, where rho is the resistivity of the material. This is a property, Okay, a property of the material. يعني it's a constant based on the material. So if you have silver, it's going to have a specific resistivity. If you have aluminum, it's going to have a specific resistivity, يعني a specific number. Lead, platinum, mercury, اللهم ما جرى كلها يعني all of the items, all of the materials that you can think of, they have a specific property. يعني related to that property is the resistivity of the material. تمام? The resistivity is that, and then we have the length. This is how long, basically, the length of the wire, how long the wire is, which is transferring the current or allowing the current to flow. And then this is the area or the cross-sectional area of the wire. So if the wire, or for example, let's say it's a circular wire most of the time, it depends on that area, the face of the wire. So let's say this is a wire we have over here. All right. This is a wire. Wire تعبان شوي. Let me redraw that to make it a bit clearer. So let's say we have a wire. يعني I'm making it much larger here, but this is, let's say that this is a wire, a cylindrical wire. All right. So we have a wire here. تمام? This is the area that I'm talking about. This area will affect. So it depends on how thick the wire is, basically. All right. This is the length from here all the way to the end. This is the length. And the material of it, the material will determine the rho of resistivity. Will the resistivity be given? It depends. It depends on the question. Yani most of the time, resistivity, it's not something to be calculated. These are usually experimentally calculated. However, if they give you the length, area, and resistance, you should be able to find resistivity from that. And we will see that in some of the questions. All right. So these are only the first three things that I talked about, which is the material, the length of the wire, and the area. These will always depend. These will always be factors that are important to determine resistance في أي شيء, في any material. There is one more thing, temperature, that I did not talk about. The temperature will also depend, obviously, يعني if you're considering all these factors on top of it, the temperature will also depend on how resistive the wire is. And that will depend on something called alpha, also known as the thermal or temperature coefficient. Thermal or temperature coefficient. All right. This is also another property of the material. Then this is a different property of the material. So it depends on the type of material as well, what the thermal coefficient or the temperature coefficient is of that material. فيختلف من material to material. So it's an effect of material. It does not have to do anything with the length of it, the size of it, how big it is, how small. It's a property. It's a set number depending if it is a metal, if it is, depending on what type of metal, what type of alloy, and all of that. And there are multiple equations that are used to determine this. These formulas will be given to you in the exam, so there is no need for any memorization. All right. So basically what it tells you is R, the important basic formula is R times R0 is equal to R0 into 1 plus alpha T, where this is RT, this temperature T, this is RT, all right? Meaning this is the resistance at this specific temperature. Then this is alpha 0. When we say 0, what do we mean? We mean this is the initial or at temperature, يعني the coefficient when T equals 0. 0 degrees Celsius, I should say. Okay. So this is alpha 0. RT, this is the resistance at the temperature we want. So the at temperature equal to T. And R0 is the resistance at the temperature when it's equal to 0 degrees Celsius. Tamam? So these are all the variables that we are using here. When we come to solving, we will see that they could be giving us only one of these or two of these, and we're going to have to find everything else, which we will see later on. There are also other formulas here that you can see, R1 over R2, which I will talk about later when we are solving. alpha T, which I want to talk about a bit more now, actually. So alpha T is equal to alpha 0 over 1 plus alpha 0 T. We already know what alpha 0 and the T are. This alpha T is basically the coefficient at a specific temperature T, at temperature equal to T. Remember, alpha 0, we said, is when the temperature is equal to 0 degrees Celsius. So we can also find the coefficient when the temperature is at a specific T if we are given the initial temperature, or if we're given the initial coefficient at when the temperature is 0. And this is basically everything you need to know when it comes to solving. When it comes to solving, obviously, there's going to be extra steps you're going to have to do. So far, this is what is important. We're going to be using some other formulas as well, you will see later on. But I just want to know if there's any other questions before I start solving. All right, I'm going to assume. Okay, go ahead, Mariam. No questions? All right. Anzir. So, basic question. It says calculate the resistance. I don't know if you can see this, but it says at the top, calculate the resistance of a 1 meter. So the way I solve these is I take them piece by piece and I start writing everything I have down. So it says calculate the resistance of a 1 meter length. So it says 1 meter length. So I instantly will write L is equal to 1 meter. Of a 1 millimeter squared copper wire. 1 millimeter squared copper wire. Millimeter squared means it is an area. So area is equal to 1 millimeter squared. The first step you do before you solve anything is always make sure all your units are in meters or in ohms directly. So the first thing you will do is convert this into meters. And how do you do that? You multiply. You should all know how to do this by now, but this is the technique I usually do for conversion. I always use this to avoid confusion, especially if there's a square. So we know that first of all, this is millimeter. So we want to cancel the millimeter. We will put the millimeter down. And we want to convert it into meters, so we will put the meter up. We know that 1 meter is equal to 1,000 millimeters. Pretty sure everyone knows that right now. And remember that we are canceling squared. So we want to change this into squared. So we will have to square everything here. So if we want to solve this, it will be 1 millimeter squared times 1 meter squared, because 1 squared is just 1, over 1,000 squared, which is 10 to the power of 6, or 1 million. All right, if you square 1,000, you're going to get 10 to the power of 6 millimeters squared. And now you can see that we can cancel the millimeter squared. So the area is equal to 1 over 10 to the power of 6 meters squared, or 10 to the power of minus 6 meters squared. All right? This is how you do the conversion, or another way to write this is 1 times 10 to the power of minus 6. It's the same thing. Okay? See, so far, I just read up to the comma, and this is how much I had to solve. I make sure that you're always converting your units from the very beginning. Do not save it till the end, because you might forget, and a lot of students lose marks because of unit conversion. Tamam? Now we continue reading. Given that the resistivity of the copper wire, resistivity at 20 degrees Celsius is 1.68 times 10 to the power minus 8 ohm meter. The unit of rho, all right, they are the symbol rho, which is resistivity, is ohm meter. So I'm going to write that down. So rho is equal to 1.68 times 10 to the power of minus 8 ohm. This is the symbol of ohm meter. All right. Now I have everything. What is my formula? My formula is, it's asking us to find the resistance value. So R is equal to rho times L over A. So if I just substitute these values in, this is going to be equal to, the rho is 1.68 times 10 to the power of minus 8. The L is 1 meter. and the area is 1 times 10 to the power of minus 6 meters squared. All right? See, everything is in meters. Make sure that's the case. We have this in meters and ohms. That's perfect. We have this in meters squared, and we have this in meters. So as long as all the units are correct, we can go ahead and solve. We could just put this in the calculator, and you will get a value of 0.0168 meters. Keep in mind, the question says up to 4 decimal places. So make sure you are putting it in 4 decimal places. 1, 2, 3, 4 decimal places. All right? Any questions about what I did here? This unit conversion, you really need to understand what I did here because you will have to do this. Oh, sorry, it's ohms. Yes, my bad. Ohms. We're talking about resistance. Resistance, the unit of resistance is in ohms. All right? Any questions so far? It's clear. The conversion is clear. This is the most, like the actual solving is easy. The mix-up is going to happen in the conversion. So make sure you understand how to convert your units. هذا أهم شيء in the exam. All right? Let's move on to the next question. A coil is formed. Let me just make this a bit bigger. A coil is formed by winding 234 turns of copper wire. Winding معناته يعني يلفونه. يعني they're basically, rotating it around a cylinder. All right? So the number of turns is usually represented by the letter N. It's equal to 234 turns. So how many times they turned it around? كم لفة سووها? The wire has a diameter of 1.44 millimeters. So D is equal to 1.4 millimeters. This is in millimeters and we need to convert it into meters. So this is equal to 1.4 times 10 to the power of minus 3 meters. What I did here is, it's simply, if I want to do it the way I showed you earlier so you don't get confused by the shortcut, how do I convert? You multiply by 1. What do we have? We have millimeters. We want it in meters, so we put meters up. What do we want to cancel? Millimeters. How many millimeters in 1 meter? It's 1,000. So this is going to cancel, and this will be equal to 1.4 times 1 over 10 to the power of 3. And 1,000 is 10 to the power of 3. So in other words, we can write it as 1.4. If we just take this up, it's going to be times 10 to the power of minus 3 meters. Tamam? So that's the first step, converting it into meters before solving the question. Now, it is wound in a single layer on a cylindrical former of radius 12 centimeters. 12 centimeter radius. So this radius of this cylinder over here, the radius of the cylinder is equal to 12 centimeters. Again, I want to convert this into meters. So 1 meter over 100 centimeters is in 1 meter. Centimeter and centimeter will cancel. This is like saying 12 times 1 over 100 meters. Or, yeah, 1 over 100 meters. So if I want to just simplify this, this is going to be 0.12 meters. Or I can write it as 12 times 10 to the minus 2 meters. It's the same thing. All right. As you notice, I have finished reading the question and I make sure everything I have so far is in meters. It says, note that the resistivity of the wire is, which is rho, is 1.74 times 10 to the minus 8 ohm meter. So this is already in proper units. We don't have to change anything. Now, we are given all of this. First, let us find the area of the cylinder, all right? Or sorry, the area of the wire, not the cylinder, the area of the wire. Remember, we are trying to find the resistivity of the wire or the resistance of the wire. So we need to find the area of the wire, not the cylinder itself. So the diameter here, this diameter is the diameter of the wire, all right? It says the wire has a diameter of 1.4 millimeters. So let us find the area. What is the area of a circular, any circular object? It is pi d squared over 4. So the area of wire is pi times the diameter of the wire squared over 4, which is pi times d is 1.4 times 10 to the minus 3, all squared. Make sure you're putting everything in brackets when solving, putting the squared outside, divided by 4. So this, if we simplify it, this is going to be 4.9 pi times 10 to the minus 7 meters squared. We're talking about area. Area is in meters squared because the diameter is in meters. Okay. I kept the pi outside here because I will show you that later on it cancels. I usually solve it this way. You can simplify it. And you can multiply 4.9 times pi in the calculator. You're going to get a number. It's fine. Nothing wrong with that. I prefer solving this way because it is a bit more accurate and you will see in a bit why. خلصنا الحين من area of the wire. Now we need to find the length of this wire. صح? Remember, we are trying to apply this equation at the end of the day. We're trying to apply R is equal to rho L over area. صح ولا لا? So we found the area. The area, we found it. The rho is given. Now we need to find the L, the length of the wire L. So how can we find it? If you notice here, the length of the wire is circular, going around this a specific number of times. So it's turning around it a specific number of times. فمعناته it is the circumference of this cylinder and then times the number of times it turns around it. So then times the number of turns بما معناه. So we can write it as the number of turns, or let's say it is the circumference of the circle. So it is the area, the circumference, the equation of it is 2 pi r, r of the cylinder, times the number of turns there is of this wire around the cylinder. And it is going from here to here, all 234 times around this cylinder. So the distance it's covering is the circumference of the cylinder. So this is the circumference, and this is the number of turns. All right. And we just substitute. So 2 pi RC we have it as 0.12 times, we have the number of turns to be 234. So this is equal to, just put it in the calculator, it's going to come to 56.16 pi. Okay. Again, you can multiply it into the pi. I didn't want to simplify it more because eventually they will cancel out, as you will see now. And now we found the L. So we have our rho, we have our L, we have our A. We can find our final resistance value. So the resistance is going to be equal to 1.74 times 10 to the power minus 8. All right. 1.74 times 10 to the power minus 8. This is our rho. Times the length. The length was found to be 56.16 pi. Divided by the area. The area is 4.9 pi times 10 to the power of minus 7 meters squared. Okay. If you notice, we have pi over here and pi over here. They're just going to cancel out. So if we simplify this, we find out that R is equal to 1.9943 ohms. And that's how you basically solve it. Again, the question mentions up to 4 decimal places. So 1, 2, 3, 4 decimal places from where the decimal point is. All right. So 4 decimal places. Is it clear so far? Does anyone have any questions about this question? About the solution to this question? Okay. Moving on. Again, very similar type of question. A coil consists of, again, 850 turns. So I will write من البداية N is equal to 850 turns. of copper wire having a cross-sectional area. The area is 0.22 millimeters squared. So area is equal to 0.2 millimeters squared times 1 meter over 1000 millimeters all squared. And then we're talking about squared. So this is going to be equal to 0.2 millimeters squared times 1 meter over 10 to the power of 6 millimeters squared. Cancel, cancel. So بيبقى لنا 0.2, the area is 0.2 times 10 to the minus 6 meters squared. تمام? We found the area in meters. Moving on. The mean length, so this is length L, the mean length, يعني the average length per turn. شو يعني length per turn؟ يعني L over N. Length per turn. لأن N is the number of turns. L is L over length over the turn is equal to 40 centimeters. تمام? Again, the mean length, it's saying per turn. Per turn معناته per N, per every time it turns around the coil. يعني every time it turns around the cylinder or whatever. Okay? So L over N is equal to 40 centimeters. Again, we want to convert this into meters, so we just multiply by 1 meter over 100 centimeters. Cancel, cancel. This is going to give us 0.4 meters. All right? So L over N is equal to 0.4 meters. Tamam? Before I even move forward, we already have the number N, or the number of turns. So we can already find the length L by just moving N to the other side. So 0.4 times N, which is 0.4 times N is 850. So the length L is going to be equal to 0.4 times 850, which is 340 meters. Okay? Let's move on by reading the question. The resistivity of the copper wire is 0.04 micrometers. So rho is equal to 0.04 micro ohm meter. Notice one thing here. There is a micro in the sign. So this micro we need to get rid of. We need to convert it into just ohm meter. Same exact idea. 1 micro, just so you guys know, 1 meter is equal to 10 to the power of 6 micrometers. All right? So if we want to cancel this, we're going to multiply by 1 meter up top, and the bottom is going to be 1 or 10 to the power of 6 micrometers. So the micrometer will cancel, and what will be remaining is just the meter up top. فبيستوي rho is equal to 0.04 times 10 to the power of minus 6. The minus 6 will go up. This cancels as well, micrometer. Ohm times what is remaining, the meter. So we converted this now into meters as well. All right? Remember that micro is 10 to the power of 6. When you have micro, it's 10 to the power of minus 6 actually, but when you're comparing it to meters. All right? فالحين we have everything in meters. We have the area. Yes, we have the length, and we have the resistivity. Now we can find the actual, whatever the question is asking for us. So the resistance of the coil, R, what do they want? They want that. So the R is going to be equal to, again, it's the rho, which is 0.04 times 10 to the minus 6 ohm meter, times the length. The length is 340 meters, divided by the area, which is 0.2 times 10 to the minus 6 meters. Therefore, the resistance is equal to 68 ohms. تمام? 68 ohms. It says to do decimal places, so it's going to be 68.00 ohms. تمام? Just make sure of that because it says up to 2 decimal places. The second question says the power P absorbed by the coil. Now, I didn't talk about the power much, but what you need to know, it's also available in the formula sheet. The power is also related to to the voltage and to the current. So the power is equal to the voltage times current, or if we are applying Ohm's law, we can say that it's equal to the voltage squared over the resistance as well. Or we can say that it's equal to, if I'm not mistaken, the current squared times the resistance, I think. Let me just double check with the formula sheet. Yes, exactly. Okay. Because this is just a rule. We will discuss more about this in the upcoming sessions, inshallah. But for now, just know that this formula exists and it's also on the formula sheet, so nothing to worry about. No memorization required for now. All you need to know is I squared, this part of the equation for now, which is V squared over R. All right? Why do we need this? Now let's read the question. The power P absorbed by the power P, this power P, absorbed by the coil when connected across a 110 DC supply, meaning it's a 110 voltage DC supply. So we are given that the voltage V is given as 110 volts DC. Again, we will discuss that more. I just want to show you how you would solve this. So the power is going to be equal to voltage squared over the resistance, which we already calculated earlier. It's 110 squared over 68 ohms, which is equal to 177.94 watts. And again, 2 decimal places because the question asks for 2 decimal places. Don't worry too much about this part, all right? It's just, as you can see, it's just applying a formula. Formula is given in formula sheet. We'll solve more problems related to this more clearly later on. But the idea is understanding how to convert, understanding when they say mean length per turn, what they mean by that, which is L by N, and understanding how to find out what are the requirements, which is the rho, the area, and the length to find the resistance of a material. So far, we're only solving questions that are not involving temperature. As you notice, it's all about the material, size, and area of the material instead. Any questions so far? All right. Let's solve this question. An aluminum wire. All right, an aluminum wire. This will require a little bit of focus so you guys don't get too confused. An aluminum wire 7.5 meters long. So first of all, we are given an aluminum wire of 7.5 meter length. So the length of the aluminum wire, is equal to 7.5 meters. All right, it's given in meters. There's nothing we need to change about this. Nice. Is connected in parallel, which we will need to look at later on in parallel, with a copper wire 8 meters long. So I'm going to write the copper in red and the aluminum in green. So LC is equal to 8 meters in length. When a current of 9 amperes is passed through the combination, so the total current, I total, is equal to 9 amperes. When it passes through both, it is found that the current in the aluminum wire, so the IA, is equal to 6 amperes. So it's equal to 6 amperes. What does this mean? This means since they are connected in parallel, all right, since they're connected in parallel, I'm pretty sure you guys read that in your classes. When two wires are connected in parallel, all right, so let's say this is voltage, and then we have 2 wires connected in parallel, the current here going in is going to be split between these two. So this I is equal to I1 plus I2. All right, I1 plus I2 is equal to the total current when they are in parallel. So here they're saying the aluminum and the copper are in parallel. Tamam? That means the copper, the IC, is going to be equal to I total, or I should rephrase this so it can be a bit more clear. I total, again, is going to be equal to IA, which is the current along the aluminum, plus I C, which is the current across the copper, because they're connected both in parallel. بالمنطق يعني if you have flow زين إذا أنتوا عندكم مثل ما قلت marbles, if you guys have like 10 marbles, okay, and you have like 2 holes, okay, that are stand side by side, and you have 2 roads going to these 2 holes, and you just put all the marbles randomly throw them, you will have to have an equal number of marbles. يعني you're gonna have like, let's say 5 here and 7 here, but when you add them you're gonna have to have the same exact total number of marbles you started with. يعني you cannot have any marbles missing left and right, they have to go somewhere. نفس الفكرة هني. So when the current starts from here, it is going to be distributed here and here, depending on resistance, depending on a lot of things, which we'll talk about later, but they will be distributed equally. So when you add them back up, they have to equal the total current. And this is what we're doing here. So we know that the total current is 9. We know that one of them is getting 6. So what is remaining? 3 amperes for the other one, so that the total will be equal to 9. So this is 9 is equal to 6 plus IC. So IC is going to have to be equal to 9 minus 6, which is 3 amperes. So now we know that IC is 3 amperes because they are connected in parallel. تمام? Now it says the diameter of the aluminum wire is 3 millimeters. So the diameter of the aluminum wire is 3 millimeters. Again, we're going to just convert this directly into meters. It is equal to 3 times 10 to the minus 3 meters. All right, I'm just going to do it quickly as a shortcut. And the resistivity of the copper. So this is the diameter of the aluminum wire. All right, and this is the resistivity of the copper wire is 0.016 micro ohm meter. So the resistivity of C, the copper, is 0.016 micro ohm meter. So if we want to just convert this into meter, it's 0.016 times 10 to the minus 6, which is micro ohm meter. All right? That of the aluminum is, so the aluminum one, the aluminum resistivity is 0.027. So 0.027 micro ohm meter. صح? Yes. Again, we're going to have to, this is aluminum A. We're going to have to convert this into times 10 to the minus 6 ohm meter. Then, before I continue solving, is this clear for everyone? Raise your hand, give me a reaction. I want to know that you guys يعني فاهمين علي شو قاعد أقول؟ واضح المعلومات؟ راقدين قاعدين تفكرون في السحور؟ أبغى أعرف معاي، أحس قاعد أكلم نفسي لنا شوي. I just want to make sure. Is everyone okay? Everyone's understanding? Kind of? Yes? No? إنزين. تمام. Moving on. We just read the question and got all the information for each material. So we have 2 different materials. Obviously, 2 different resistances will be there. تمام? We have the aluminum and we have the copper. So what is the question even ask? The question is asking the diameter of the copper wire. So we need to find the diameter D of the copper wire. This is what we need to find. Let me actually change the color of this so we know that this is what we need to find. Okay, so we need to find the diameter of the copper wire. Now, first, let us work with what we know. Let us work with what we know. أول شيء, we know that R for aluminum is going to be equal to the resistivity of aluminum, the length of aluminum over the area of aluminum. صح ولا لا? Same thing with copper. The R of copper is going to be equal to the resistivity of copper, the length of copper over the area of copper. All right? This is the first thing we need to know. We are 100% sure of this. تمام? Let's see what we have and what we don't have. What we have is, let me do it in purple. So what we have is we have diameter, so we can find the area. All right, we need to find the area, but we have the diameter for this one. We have the length of both. So we have the length. We have the length. And we have the resistivity of both. Okay, so what is left is the AC, which we need to find to determine DC anyways. But we need to find a way to relate RA with RC. Two things you need to know here. So remember when I said this is in parallel? I'm pretty sure all of you know by now that if two lines are in parallel, the voltage must be the same for both. So the voltage of A should be equal to the voltage of C. All right, because they are in parallel. So we know that VA is equal to VC. And what does Ohm law say? Ohm law says that V is equal to IR. فبنعوض. We'll just substitute that. So IA RA is equal to IC RC. And we already have IA and IC that we found earlier, IA and IC. And now we can start solving. We just have to substitute RA back into this equation and RC back into this equation, and we will have to solve for AC. But before we do that, let's just find AA very quickly. AA is equal to pi dA squared over 4, which is pi dA is 3 times 10 to the minus 3 squared over 4. Therefore, AA is equal to 2.25 pi times 10 to the power of minus 6 meters squared. Tamam? So we found our AA. We have every other value. So we could just plug this in back here. So if we plug it in, just so you know how it will look like before I plug in more numbers, we're gonna have, so IA, we're gonna have IA times RA. What is RA? RA is rho A, which is resistivity of A, LA over AA. Tamam? This is equal to IC over here, and we'll substitute RC for this. So we'll put these values in. Rho C LC over AC. Okay? So this is what we have done so far. We just substituted everything back in, no confusion. But keep in mind, we have the values for all of these numbers, except for one, AC. So we need to solve this equation using transposition, if you remember from back either in foundation or even back from school. Right now, let us solve for AC before we put in all the numbers and it gets messy. Zain. We could just directly, there's one of two ways, honestly. And I prefer I solve it with variables, then put in my numbers, or you can plug in all your numbers and simplify it and then just solve for AC. That's up to you. But I prefer solving it in letters because it gets very confusing with numbers. For the AA, when we do calculate it in the calculator, we use the radians, right? If you have the pi symbol, you do not use radians. Look, radians and degrees only come into effect in electrical. It will never come into effect. Maybe it does. I'm not sure. Not at this level, at least. It is only when you are dealing with angles. When you are dealing with angles, this is when it will affect. So if you have in electrical fundamentals, you're not going to be dealing with angles. بما معناه, if you're dealing with sine, cosine, angles, that stuff, this is when pi will affect radians and degrees. If you're not using sine, cosine, pi is always going to just be equal to 3.14, whether your mode is in radians or in degrees. It is always going to be 3.14. It is when you're applying the sine and cosine trigonometry, that's when your calculator needs to be in radians. Okay? So let us solve. Let us solve, no problem. I'm going to solve this and while not plugging in any numbers. Again, you could do it in any way you want. I'm just going to make it a bit easier. I'm going to distribute everything over AA is equal to IC rho C LC over AC. So the first thing I'm going to do is cross multiply. Cross multiply. To get rid of denominators, have them all up. So AC times IA rho A L A is equal to AA times IC rho C L C. Again, we're trying to solve just for AC. We want AC to be by itself. Okay? So we're going to divide both sides by IA rho A L A. So basically, I'm just going to take this part and take it to the bottom here. That's all I'm going to do. So AC is equal to AA IC rho C LC divided by IA rho A L A. We have all these numbers. Now we can come back here and plug them in one by one. So AC is equal to AA. We go back, we find AA. It's 2.25 pi. 2.25 pi times 10 to the minus 6. IC we found earlier was 3 amps. Rho C was 0.016. 0.016 times 10 to the minus 6. And LC, at the very beginning, was 8 meters. All divided by IA. IA was 6. Rho A was 0.027. Times 10 to the minus 6, sorry. Times 10 to the minus 6. And then we have LA, which I think was 7.5. Yes, 7.5. And put this all in the calculator. It will give you AC is equal to 2.234 times 10 to the minus 6. Okay, meters squared. Keep in mind, this is just AC. The question wants us to find DC. So what is the formula of area? AC is equal to pi DC squared over 4. If we rearrange this, we will get DC squared is equal to 4 AC divided by pi. So DC, if we just do the square root here, it cancels. It's going to be equal to the square root of 4 AC. So DC is going to be equal to the square root of 4 times 2.234 times 10 to the minus 6 all over pi. Put this into the calculator. DC is going to be equal to 1.69 times 10 to the power minus 3 meters. Now keep in mind, when we go back to the question, it is first saying answer up to 2 decimal places, okay? And it wants the answer in millimeters. So we're going to have to convert this back into millimeters. So how do we do that? So DC is equal to 1.69 times 10 to the minus 3 meters times. Now keep in mind, we want to get rid of meters. So the meters will be down. And we want it in millimeters. So millimeters will be up. 1 meter is how many millimeters? 1000 millimeters. So the meter and meter will cancel. DC is equal to 1.69 meters, millimeters, sorry. And at 10 times 10 to the power minus 3 times 1000 is just 1. Tamam? And this is your final answer. See how long the question is. It is not difficult. It is just very time consuming and you can make a lot of mathematical mistakes throughout solving. So just make sure you're going through it step by step. The idea here, the trick here is to understand when in parallel voltages are the same and the currents add up. This was the trick to it, which we will talk more about later on, inshallah. But when it comes to the resistivity part, as you see, we can relate it to Ohm's law, which is V equal IR. And then we can solve for any like requirement given by the question. Let's take a 5-minute break. زين. Just 5 minutes until 11:10. All right. I just want to go grab some water لأن صوتي بدأ شوي يروح. We will continue with the remaining questions إن شاء الله. Yes, it is recorded. All right, let us continue. I'm going to try to solve a bit quicker now because I want to get into temperature as well. Again, when you read the question, take the notes instantly. So calculate the resistance of a 0.5 kilometer long. L is 0.5 kilometers. Kilometers معناتها 1000. So you multiply it by 1000 to get it into meters. So this is 500 meters. Composed of 20 stands. 20 stands, which I'll talk about in a minute. It's strands actually, not stands. Strands, this is a typo. 20 strands of similar copper conductors. So they're all the same. Each strand being 1.22 millimeter in diameter. So the diameter is 1.22 millimeters, which is equal to 1.22 times 10 to the minus 3 meters. In diameter, allow 5% increase in length for the twist or the lay of each strand in a completed cable. What does that mean? معناته ان length انزين of each one, because it is twisting around, is going to be increased by 5% length. In other words, this means you're gonna have, and you have 100% length, you're gonna add to it 5 more percent, so you have 105% times L of length. So the total actual length, L total, is going to be 1.05, which is 105%, times the 500 meters, which is equal to 525 meters, okay? Because there's an increase in the length, you need to make sure you are compensating for this increase in the actual total length of the wire. So the 5% increase in length, the resistivity is given as 1.74 times 10 to the minus 8 ohm meter. So what does strands mean? Strands mean يعني إذا عندكم if you see like cables, there are multiple wires next to each other. زين? So you have different number of wires next to each other. All that will add. The length is not going to change, but what will change is, if you notice here, you're going to have multiple areas. You're going to have 1, 2, 3, etc., depending on how many strands you have. So we have 20 strands. We're going to have to multiply that by the area because that's the amount of area we're going to have. That's the only idea. So if we find the area is equal to pi d squared over 4 times the number of strands in this case. That's the only trick to this question, okay? The 5% increase in length and the number of strands. So if we just calculate that, it's going to be pi times 1.22 times 10 to the minus 3 over 4 squared times 20, which is the number of strands. So the area is going to be equal to 2.338 times 10 to the minus 5 meters squared. All right. And that's it. We have area, we have rho, we have the length. We can find the resistance value instantly now. So R is going to be equal to 1.74 times 10 to the minus 8 times the length 525, remember, not 500, over 2.338 times 10 to the minus 5, which is equal to 0.391. It says up to 3 decimal places, so 391 ohms. Keep in mind in Moodle, it says 3.98. In Moodle, it's wrong. This is the actual correct value. So if it's fine, if you solve it on Moodle and you get it as wrong, this is the actual value. I have double checked this. Okay. Yeah, and that's pretty much it for this question. Let's go to the next one. All the questions I'm solving here, these are all Moodle questions. If you go to week 1, you're going to see exercises there on Moodle itself, and you can solve them there. I believe the numbers might change, like every time you try to solve the quiz, the numbers will change, but the question is exactly the same. And I'm going to be sharing this document with you guys after the session is done as well. Okay, so a lead wire and an iron wire. So we have two wires. We have a lead wire and we have a iron wire. And they are connected in parallel. So remember, they're in parallel. The respective specific resistances are in the ratio of 48 to 33. What does this mean? Ratio. Ratio means division, basically. So if you have 48, 33, this is the same as saying 48 divided by 33. But what is it saying? It's saying the order, it says respective. So yani the order of it is the resistivity of lead over the resistivity of iron. When it comes to ratios, the order matters. So yani when you say a lead wire ratio of lead to iron, this is how you write the ratio of lead to iron. All right? So it's just division. Ratio is basically just division. Okay, don't get confused by that. The former carries 60% more current. The former, what do they mean by the former? يعني الأولي, the one before it. So what was the first one? The lead wire. So the former has to do with lead. So it says the former carries more current. So what is current? Current is I. So the I of lead carries 60% more than the current of the latter, which is the iron wire. So I of iron. All right? More than the I of iron. Okay? What does this mean? Again, when they're saying a 60% increase, this basically means 100% plus 60%, which is equal to 160%. معناته if I rewrite this, I of lead is equal to 160% of I of iron. In other words, 160% means 1.6 times I of iron. تمام؟ لأن percent is just divided by 100. All right? So we know that I of lead is equal to 1.6 times the I of iron, the current of iron. And then the latter. And the latter, which is iron, is 35% longer, يعني length longer than the former. Again, we do the same thing. So L of iron, the latter, which is iron, is equal to 35% more. So يعني 100% plus 35% of L of the former, which is L of lead, the length of lead. تمام? So if we rewrite this, this is 135%. So this is going to be equal to 1.35 times the L of lead. تمام? L of iron. So we notice here it's all relation. It's all relating one to the other. What do they want us to find? This is very important here. The ratio of the cross-sectional area of iron to lead. So they want of iron, the area of iron over the area of lead. This is the ratio they are looking for. Tamam? So this is what they want us to find. The ratio of iron wire to the lead wire. So it has to be in this order. Iron first, then the lead. Again, the application is going to be very similar. They're connected in parallel, so we can use the V equal IR. So V equal IR, we can apply this, where we know that the voltage is the same. So the voltage of lead or voltage of iron is equal to the voltage of lead. زين. So when we do it into V equal IR, it's going to be the I of iron times the R of iron is equal to the I of lead times the R of lead. تمام? And now we could just substitute. We know that the R of iron, I of iron, زين. I'm just going to keep calling it I of I عشان ما أكتب وايد خرابيط. I of I, R of I is just resistivity of I, length of I, divided by area of I, okay, is equal to again the I of lead L, rho of lead L, length of lead L, all over the area of lead. زين. Remember, these are the values we need to find, the ratio of this to this. So we have to rearrange the equation so that iron is up the top and lead is at the bottom, okay? The easiest way to do this is first thing you do is cross multiply, so you do not get confused. So it will be A lead times I rho I Li is equal to A of I L rho L تمام? We want again to remind you, we need iron over lead. So we need to make sure this one is at the top and this we need to divide it and take it to the other side. So what we're going to do is take this to the bottom here and we will take this part to the other side to the bottom. That's what we're going to do. Okay, so we're dividing both sides by these so that we have it in that form. So we're going to get I rho I Li over IL rho L is equal to AI over AL. And now we just substitute for whatever we have ratios of so we can cancel the constants. يعني What do we know? First of all, we know that the row of lead over row of iron is equal to, so the row of lead over iron is equal to 48 over 33. Another way of writing this is, because at the bottom, if you notice, we have row lead, row iron, صح? Here we have row iron over row lead. So we can swap it. So we could just flip them around. So we could say that the row of iron over the row of lead is equal to 33 over 48. All I did was just flip them, and that's fine. Mathematically, you can do that. So you just flip them. So we can cancel those out as well. Okay, so 33 over 48, was it? Yes, over 48. Again, this is just this part. This part, we swapped it out with this part because of, this is 1, okay? From here, this one. All right? Now, that was the first thing we had. Now we have the current. We know that the current of lead is equal to 1.6 times the current of iron. So this is 2. This is 2, which is I lead, IL, is equal to 1.6 times I of iron. All right? The I of iron. For I lead, we will substitute here in the I lead. At the bottom, it's over here at the bottom. We're going to substitute this with 1.6 I, and we have at the top I. And then, again, this one is only merely a substitution here from number 2. And then we substituted from this one, from this this ratio we have, or this given identity, and then this given comparison. If you notice, we can simply now cancel the I with the I, so we just have a number at the bottom. We don't have any more variables. Now the last part is the length. And then the last part is the length. So the length here, the length of iron is equal to 1.35 times the length of lead. This is number 3. So we can substitute for the length of iron, this value over here. Where is the length of iron? At the top over here. This is the length of iron. We're just going to substitute by 1.35 the length of lead over 1.35 LL over LL. LL and LL will cancel. Again, this was just a substitution from what we already had. So if I just want to clarify it a bit more, عشان it doesn't look too confusing, we have at the top 33 times 1.35 divided by 1.6 times 48, and this is going to give you, the answer of this is just going to give you the ratio, which is 0.58. Again, on Moodle, this is going to give you a different ratio. I double checked my work 10 times. This is the actual correct ratio. On Moodle, even if it says it's wrong, this is the correct method to do it. Tamam? Moving on, here I know it can get a lot really confusing, but just make sure you're labeling everything properly, you're writing your steps clearly, so when you're doing your substitutions, you know how you're substituting correctly. Remember, this again applies the V equal IR Ohm's law, where parallel voltage is always going to be equal, and then you just substitute all the values you have to determine the ratio. Last question we have here of without temperature, just material. A piece of silver wire has a resistance RS, let's call it RS, is equal to 6 ohm. Okay, so here they're giving us the resistance directly. The length of a manganese wire of 1/5 the length. Yani, what does that mean? And 1/3 the diameter, and the specific resistance of manganese is 48 times that of silver. So they're comparing this with silver. So the length of manganese wire, the LM, is equal to 1/5 of the silver wire. And the diameter of the manganese wire is 1/3 that of the silver wire. Oh, sorry, the silver diameter. Okay? And the specific resistance of the manganese is 48 times the resistance of the silver one. All right? So they are giving us already full relations between both the silver and the manganese, and they already gave us the resistance of silver. They're not saying these are in parallel or anything. They just want us to find the resistance of silver directly. This isn't silver, actually. They want us to find the resistance of manganese because they gave us the resistance of silver. All right? So they want us to find the resistance of the manganese. So what is Rm? Rm is what we are trying to solve for. Very simple. First of all, we know that Rm is equal to rho L, rho M, Lm over Am. صح? And we know that R of silver is equal to rho S, Ls over As. So the way to solve this is something called division. We just put a huge division sign here and we solve. That's it. So basically we divide everything up here by everything down here. What it will look like is this. So it will be Rm over Rs is equal to, because there's an equal sign, it's going to be equal to rho M Lm over Am. Okay? All divided by rho S Ls over As. Rho S Ls over As. So when you have division like this, the rule in math, I don't know how you learned it before, but how I was taught is the numerators, these numerators, you're going to multiply, and the denominators, you're going to multiply with each other, and the solution is going to be the numerators up top, which is rho M Lm times As, and the denominators are going to be at the bottom. So Am rho S Ls. Let me actually rearrange it so that everything related to each other is in front of each other. So rho S Ls Am. Again, the further away ones, these are going to be your numerator. The closer ones, هذول بيكونون denominator. Okay? This is always the rule in math. Just make sure you're doing it properly and you'll never get confused. So that's it. So we already have these relations where we're going to substitute now, and you're going to see how it's going to work. But we have one thing. Here we are given areas. Here we are given the diameters. So let's do one extra step. So we know that As is equal to pi ds squared over 4. And we know that Am is equal to pi dm squared over 4. So let's just substitute this back into the equation. So we have Rm over Rs is equal to rho M Lm As, which is pi ds squared over 4. And we have rho S Ls pi dm squared over 4. تمام? The pi over 4 will cancel with the pi over 4. زين. So this will be simplified to rho M Lm ds squared over rho S Ls dm squared. As you can see, there's a lot of math that you need to know how to do here. It's mostly the math part rather than the actual electrical part that you need to do solving for. Now we have everything. We have all the relations. We can start substituting. We will just take the Rs to the other side so that Rm is by itself and we can find the solution. So Rs, we're just going to take it here. So Rs, and basically I'm just multiplying Rs over here. It's going to be rho M Lm ds squared over rho S Ls dm squared. Rho m, Lm, we have all the relations here. So let's start with the rho m. Rho m is equal to 48 rho s. So we will substitute this. Again, I'll just rewrite it. Rm is equal to Rs. We know that Rs is equal to 6. Tamam? For Rs is equal to 6 times rho m, again, was equal to 48 rho s. This is 48 rho s over rho s. Rho s and rho s will cancel. زين. This rho s and rho s will cancel. Again, الحين we'll go to the L part. So Lm is equal to 1 over 5 Ls. So 1 over 5 Ls over Ls. Ls and Ls will cancel. And then we have the ds and dm. dm is 1 over 3 ds. So dm, the one at the bottom, is 1 over 3 ds. But keep in mind, this is squared. And this is ds squared up top. So the ds squared will cancel with the ds, because this is ds squared if we distribute. But the 1 over 3 will still stay squared. Okay? Again, this is just some basic math. So what we'll be left with is 6 times 48 times 1 over 5, okay, over 1 over 3 squared. And that's it. And that's your final answer for Rm. You just put this in the calculator, and you will get that Rm is going to be equal to 518.4 ohms. All right? That's pretty much it. That's the whole solution. For any possible questions, these are most of the what possible questions can come. Let's move on to the temperature questions. I'm going to do, a lot of them are repeating, so I'm just going to do some of the more annoying ones, but let's do the basic one first so you can understand how to use the formula. So here it says an aluminum cable has a resistance of 29 ohms at a temperature of 30 degrees. What does this mean? Yani R at 30 degrees Celsius, زين, is equal to 29 ohms. So this is when the temperature is equal to 30 degrees Celsius. It says to determine its resistance at 0 degrees Celsius. So this means it's R0 we are looking for. And it says assume that the temperature coefficient alpha 0 to be 0.00043 per centigrade. So alpha 0 is equal to 0.0043 per centigrade. You can also write it as degree to minus 1, because per centigrade basically means 1 over centimeter, 1 over centigrade, 1 over Celsius, I should say. Okay? Now, remember the formula? The formula basically is, you have this in the formula sheet, R30 or R any temperature is equal to R0 into 1 plus alpha 0 times the temperature T. All right? Because we said R30, so the temperature T is going to be 30. All right? So if we just simplify this to keep R0 on one side, because remember, we are trying to find R0. So R0 is going to be equal to R30. I'm just doing basic math. I'm moving this under here. 1 plus alpha 0 T. All right? And we substitute in the values now, and you can solve. So 29 ohms over 1 plus, we're given that alpha is 0.0043, 0.0043 times the temperature T, which is 30 degrees Celsius. All right? And that's it. And then you find R0. R0 is equal to 25.69. Very simple. You just apply the formula and move on. The second question is, which is a bit more important. This is how a question might come in the exam, I believe. Yani. So it says a coil has a resistance of 18 ohms. 18 ohms when its mean temperature is 20 degrees Celsius. What does this mean? Yani R 20 is equal to 18 ohms. This is when the temperature is equal to 20 degrees Celsius. إنزين. And 20.5 ohms when the temperature is 50 degrees Celsius. So R50 is equal to 20.5 ohms when temperature is 50 degrees Celsius. Find its mean temperature rise when its resistance. Again, this says temperature rise, يعني how much it is increasing, إنزين, the temperature of it. When its resistance is, when R, let's call it RT, and then we don't know what the temperature is, we need to find it, is equal to 22.5 ohms. تمام? And the surrounding temperature is 15 degrees Celsius. So T surrounding is equal to 15 degrees Celsius. Remember, it says temperature rise, يعني how much the temperature قاعد يرتفع من ال 15 degrees Celsius. So we need to find the difference in temperatures later on. So what do we do here? Again, we will be applying the exact same formulas that we saw earlier. So we have two formulas here. First one is the R20 is equal to R0 into 1 plus alpha 0 times T, which is 20 degrees Celsius. All right? And this is the temperature at R20. بعدين عندنا ال R50. If I'm not mistaken, it's 20 and 50, right? Yeah, R50, which is, again, the same thing, R0, same formula, 1 plus alpha 0. The temperature now is 50 degrees. تمام? To solve this, we first need to determine two things. We need to find out our R0. We need to find this. Then we need to find our alpha 0. And once we find these two values, we can find the resistance at any temperature given. And these are the only two variables that will determine the temperature, the resistance at any temperature. يعني these are the parameters اللي تحتاجونها you need to find any temperature. Any resistance, I mean, at any temperature. So there are two ways of doing this. You can either do simultaneous equations, which I do not recommend. In this case, I will do the exact same thing I did earlier, which is the division method. It simplifies it much quicker. So it's going to be R20 over R50. Let's actually just, I'll put in the numbers after this. So R0 into 1 plus 20 alpha 0 over R0 into 1 plus 50 alpha 0. زين? If you notice, R0 and R0 are going to cancel, and you're only going to have one unknown, and you can start solving immediately. You just cross multiply. So R20 is 18, and R50 is 20.5. I'm just going to write that. 18 over 20.5 is equal to 1 plus 20 alpha 0 over 1 plus 50 alpha 0. Cross multiplication, we're going to have 18 times 1 plus 50 alpha 0 is equal to 20.5 times 1 plus 20 alpha 0. تمام? Cross multiplication. Simplification, it's going to be 18 plus 50, 50 into 18 is 900 alpha 0. It's equal to 20.5. We're just distributing. يعني 18 times 1, 18 times 50. 20.5 times 1 is 20.5 plus 20.5 times 20 is 410 alpha 0. Now we just solve for alpha 0. We'll take the alpha zeros to the left and the numbers to the right. So 900 alpha 0 minus 410 alpha 0 is equal to 20.5 minus 18. This is going to be 490 alpha 0 is equal to 20.5 minus, it's 2.5. All right. Now we can find out that alpha 0 is equal to 2.5 divided by 490, which is equal to it is equal to 1 over 196, which is 5 point something. Okay. I'm just going to keep it in this form because it's easier to just write down in this form. So it's 1 over 196. This is our alpha 0. Tamam? Now we found our alpha 0. We need to find our R0. We found our alpha 0. This is done. We need to find our R0. We just substitute this back, just like we usually do in simultaneous equations, we substitute it in any of these equations. But let's say we substitute it in the first equation, R20, which is 18. So 18 is equal to R0 into 1 plus alpha 0, which is given now as 1 over 196. This is our alpha 0 times 20. And now we solve for R0. So R0 is going to be equal to 18 divided by 1 plus 1 over 196 times 20. You put this in the calculator and you will find that R0 is equal to 49 over 3. All right, and I'm going to keep it in this form so that it is just, we don't have too many decimals to deal with. We found our alpha 0, we found our R0. Now we can solve the question for any temperature. So now what does the question want us to find? They need us to find the temperature given the resistance value. So we know that RT is going to be equal to R0, which is 49. Let me just write it as an equation first. Is going to be equal to R0 into 1 plus alpha 0 T. Keep in mind, we have this value, we have this value, we have this value, but we need to find this value. Tamam? So I'm just going to rearrange the equation while it's still in variables. So it's going to be RT over R0 is equal to 1 plus alpha 0T. Again, it's going to be RT over R0. I'm just going to take the 1 to the other side. It's going to be equal to alpha 0T. Now I'm going to divide this side by alpha. So RT over R0 minus 1, all divided by alpha 0 is equal to the temperature T, which is equal to, now we can substitute in the numbers. RT is given to be 22.5. 22.5. R0, we found it to be 49 divided by 3. So 49 divided by 3. 49 over 3. Minus 1, all divided by 1 over 196. Okay? Don't get confused with all of this. You could just plug this into the calculator and solve. You don't have to simplify it or anything manually. Put it the same way I'm using the parentheses and brackets, put it in the calculator and find the final answer. So the temperature is going to be equal to 74 degrees Celsius. So we found our mean temperature, but remember, the question isn't asking for the mean temperature. It's saying find the mean temperature rise. يعني how much it is getting bigger، يعني ايش كتر قاعد يتغير مقارنة لشنو compared to the surrounding temperature, which is 15 degrees Celsius. So the rise is delta T, the rise of temperature is going to be equal to the temperature itself T minus T surrounding. بما معناه 74 degrees Celsius minus 74 degrees Celsius minus 15 degrees Celsius. So delta T is going to be equal to 59 degrees Celsius. And this is your final answer. Tamam? So this is how you would solve. This is the very important thing to know, because they might give you a question like this. I believe يعني إذا أنا سويت امتحان أنا بعطي صراحة سؤال كذي لأن this will tackle a lot of your knowledge about the thermal, and it will also see your math skills if you know how to do it and simplify it to reach to the final answer. I'll solve one more question عشان ما أعور راسكم وايد لأن this question is also very similar to what I just solved. But I want to solve this question because everything else is also, again, very similar, nothing different. Same equations are being used. But this one is just using the alpha equation, which I want to use, show you how it's done. So a copper conductor has a resistance temperature coefficient, which is alpha, okay, of 0.003829. At what? At 22 degrees Celsius. So this isn't alpha 0, this is alpha 22. All right, degrees Celsius minus 1, or per degree Celsius. They want us to find the alpha resistance at 56 degrees Celsius. This is what they want us to find. Alpha 56 degrees, which is our problem. Remember the equation we had at the very beginning. We went over it very quickly, which is, it's also in the formula sheet. The alpha of any temperature, let's call this alpha T, is equal to alpha 0 over 1 plus alpha 0 T. Tamam? So this is the equation you're going to use. But now, first, we are given, what are we given here? We are given the alpha, we're given alpha T. We know the time, obviously, since we're given also alpha T at which temperature, but we need to find the alpha 0. So we have to rearrange this equation to solve for alpha 0 before anything. So if we get into rearranging, we're going to cross multiply alpha T into 1 plus alpha 0 T is equal to alpha 0. Distribute alpha T times 1 is alpha T plus alpha T alpha 0 T, I'm just distributing this inside, is equal to alpha 0. Move alpha zeros to one side, so alpha T is equal to alpha 0 minus alpha T alpha 0 T. Okay. Take the common factor alpha 0 out, so alpha 0 is out. So what will be remaining? It's going to be 1 minus alpha T times the temperature T. And now we will divide this over here so that alpha 0 is by itself. So alpha 0 is going to be alpha T divided by 1 minus alpha T times the temperature. So we have a formula now to find alpha 0 given any coefficient at any temperature. What is the coefficient? We have the temperature at 22 and the coefficient is 0.003829. So alpha 0 is equal to 0.003829 over 1 minus 0.003829 times the temperature, which is 22 degrees in this case. 22 degrees given in the question. Now we plugged in all these numbers, we have found our alpha 0 value, which is going to be equal to 4.147 times 10 to the minus 3 degrees Celsius minus 1. Okay? Now that we found our alpha 0, what was the question asking for? It was saying find the resistance temperature coefficient at 56. So we can apply the original equation again. This equation, we can apply it one more time here. Now that we have alpha 0, الحين we have alpha 0. Okay? We have the alpha 0. We just need to find alpha T. And at what temperature? At the temperature of 56 degrees Celsius. So alpha 56 is going to be equal to alpha 0, which is 4.147 times 10 to the minus 3 over 1 plus 4.147 times 10 to the minus 3 times the temperature 56. You put this into the calculator and you're going to get you're going to get it this way, 3.365 times 10 to the minus 3 degrees centigrade minus 1. But keep in mind, the question asks this. Express your answer up to 6 decimal places. So let's put it back into normal form, not in scientific form. So this is equal to, remember, 10 to the power of minus 3 معناتها we're just going to move the decimal 3 times. So 1, 2, 3. We're going to move the decimal here, and there is going to be zeros over here. So if we're going to rewrite this, it's equal to 0.003365. This is 1, 2, 3, 4, 5, 6, 6 decimal places, which is 3 centigrade. And that's our alpha 56. And that's it. Other questions, again, are very similar. I'm not going to go through them right now. I feel like I went through a lot of questions. The same applications, you're using the same applications. There, you're just combining some other equations with them. Again, you're given all these equations. You don't have to memorize equations, but you have to understand how to solve. Obviously, you need to know the areas, the basic areas of a cylinder, of a circle, the circumference of a circle. Yani this goes without saying. You need to know your units, meters. Yani you need to know these. You need to know that 1 millimeter, or I should say 1 meter, is equal to 10 to the power of minus 3, or to the power, let me do it this way actually. 10 to the power of minus 3 meters is equal to 1 millimeter. Or in other words, 1 meter is equal to 10 to the power of 3 millimeters. اللي هو 1000. What else you need to know? You need to know that micro, then 10 to the power of minus 6. Again, if I write it the same way, 10 to the power of minus 6 meters is equal to 1 micrometer. تمام? So يعني if you want to do direct conversion. What else is there? Centimeter, again, 10 to the power minus 2 meters is equal to 1 centimeter. تمام? Kilometer, 1 kilometer is equal to 10 to the power of 3 meters. تمام? And that's pretty much it for conversions. I don't think there's anything else you might have. Just review your conversions as well. مثل ما شفتوا, the most difficult part of this is not the actual material, it's the math of it. I'm pretty sure I did, يعني I explained the idea of the theory as much as I can. راويتكم how you have to do the solving. In my way, I'm not sure, يعني I didn't even refer to how the solutions here are done. I just did it in my way and I hope it was helpful. If you have any more questions, please let me know. This is going to be the end of week 1. Next week, inshallah, we will start with week 2, 3, and 4 all together, I believe, if I'm not mistaken, or just week 2 and 3, because later on, everything is going to be jumbled into each other. Everything's going to be used together, and we're going to solve as many questions as we can, just like we did today. That's the idea. If you have any questions now, feel free to ask for the next 5 minutes. I'll be around, but the session is now completed. For now, I hope that you found that this was useful. If you guys really are not finding this useful at any point, you have to let me know. عشان I just have to find a way to يعني أوصل معلومة بطريقة أحسن.